Welcome back to the tutorial series on gravity data processing using the DGS MATLAB applications. In the previous video, we saw how we could import the data and calculate the cross-coupling coefficients. It was important to note that the calculated cross-coupling coefficients are listed here in the CC gains panel. Also, it is important to note that once everything is calculated, the process log panel here will show the total number of intersections, the mean absolute error, the mean absolute error after a cross-coupling correction is applied, the mean absolute error if you applied a DC adjustment only to the lines. So you can know that a DC adjustment is basically a form of zero order leveling, where the data is simply adjusted by the average of the intersection errors along the line. And so it would perform some of a statistical leveling. And then finally, we have the error if you applied the cross-coupling coefficients as well as the DC adjustment. So for this video, we are going to see how we can use the results menu to assess our results. So from the results menu in the dropdown, we can select show cross-coupling corrected error first. So when you select that, you note in this process panel, it gives us a list of all the intersections and the intersection differences. So for example, we have the intersection difference between line 9 and line 7 at 0.10675. And the intersection difference between line 12 and line 7 is 13.2491. So here you'll be able to see if you have any intersections with anomalously high values, and even take them out of the calculation and take them out and then recalculate the cross-coupling correction. So we already have one high value here of 13.2491, the intersection between line 12 and line 7. So we can check which is line 12 here. Sorry. So if you click on Control and simply toggle between clicking and clicking and removing line 12, you can see exactly where it is, and line 7. So the problematic intersection between this vertical line and this green line here. However, there is an easier way to visualize this. In the results, we can similarly see the intersection errors after applying a cross-coupling correction and DC adjustment. So here we can see the intersection errors between the different lines listed in the log panel here. Similarly, we can opt to see the error in form of dots, which is a more visual representation of the errors. So I'll click on the show cross-coupling error dots, and maybe we would like to see errors that have values greater than 10, or any that you'd like. So we'll keep 10 for now. So there aren't any. So let's see any errors greater than maybe 5. None. Okay. Okay, so we have a couple of errors greater than 1 millicals. and you can see that they're along this diagonal line. So if we would like to know what line that is, and maybe you think that's the problematic line that you'd like to take it out of the next calculation. So if I select on it, that's line 8. So I could hold down and control and click on 8, and it would take it out. Leave it there for now. Let's analyze the error dots if we applied both the cross coupling and DC adjustment. So any errors greater than 1. There aren't any. So maybe we can go lower. Okay. So the intersection errors in this data are pretty small. So we have a couple greater than 0.1 along these two lines. So this is just to show you how you can assess your results. So you can see the list of intersection errors here, or plot dots of errors greater than a certain value, any threshold that you may have. And also finally, you can see an error distribution plot generally. So it typically should be a normal curve. So we'll define 9 bins. Okay. Okay, so there we have a histogram of the crossover differences. Let's try another one. So maybe 5 bins. And the typical should be about a normal distribution. Okay. Now, if you do identify any problematic line and you would like to recalculate your cross coupling coefficients, for example, we saw that we had one line that had values greater than 1, this line. So if I would like to take that line out, for example, I've identified by clicking on it and checking the bottom right corner that that is line 8. So I'll just simply come and deselect line 8 and then go back to the calculate and calculate grid misdies again. Again, if you would like to assess it again, I would not apply the cross coupling corrections yet, so I would maintain no. And I would not save the file just yet. So I have, let's say, no. Okay, so with that, you have recalculated coefficients without that, and we can assess the results again. So that's basically how you can assess your intersection errors using the results menu. And based on your assessment, then you can either deselect some lines and recalculate your coefficients depending on which lines may be bringing in anomalously higher values. So in the next video, we will see how we can export the cross-coupling corrected data.